Hello, my name is Aradhya Verma from the Manipal Institute of Technology, and this is a demonstration of the Retrieval-Augmented Generation or RAG service I built. The goal was to create a system that can crawl any website, understand its content, and then answer questions based only on the information it collected, complete with source citations. This is the simple web interface I built to drive the application. As mentioned in the deliverables, we were told to focus on HTML text, so I will be using this normal, simple, fast crawl. We also have an option, the deep crawl option, which uses a headless browser to handle modern JavaScript heavy websites. We also have the option to crawl just the URL, provided if we want faster results. We will be crawling 30 pages for this demo. The process will take a couple of minutes, which is a perfect time to walk through the code. So I can see we'll reload it and fast scroll. So yeah, as you can see here, the fast scroll has started, and the first part of this pipeline is located in main.py. It is designed to be a polite and responsible web citizen. It starts by reading the site's robot.txt file to ensure it's allowed to access pages. It also uses the TLD extract library to ensure it never leaves the original website domain. As it crawls, it uses beautiful soup to clean the raw HTML and extract the plain text. Once the text is cleaned, it's passed to the indexing step here in indexing.py. The text from each page is broken down into smaller overlapping chunks. These chunks are then converted into numerical vectors using a sentence transformer model and stored in a local file syntax, which allows for incredibly fast similarity searches. As we can see, all the pages are almost done. We did crawl 30 pages and the indexing is now complete. Indexing is now starting, I'm sorry. So yeah, I think we can ask a question now. Yeah. So we can ask a question. Let's say, is there any relation between AI and aliens? So it takes a few seconds to get the answer, and till the time we can go to qa.py. This is where the final retrieval and generation happens. The QA script finally takes the question and finds the most relevant text chunks from our index. To ensure high accuracy, it uses a two-stage retrieve and re-rank process. Then the top ranked chunk are passed to a local AI model using Olama. The key is this hardened prompt here. So as you can see, the answer has been there, and we can see the metrics for just this answer. In the end of this demo, I'll show you the report, which has everything with the average, the median P50, and the P95 percentile as well. So before that, let's check our safety guardrails. What happens if we ask a question that cannot be answered from the called content? Let's just say, what is Black Panther's suit made from? Yeah, so the system should recognize this information is not there and politely refuse to answer. Yeah, as you can see, I do not have information to answer this question with the metrics as well. Finally, to satisfy the observability requirement, I built an evaluation script as well that runs a batch of queries to measure performance. We can just run evaluation.py, and this script dynamically generates its own questions from the content we just indexed, then runs them through the pipeline and records the performance of each one. The final report gives the scheme latency metrics like the average, the P50 median, the P95 percentile. This is essential for understanding and improving the system's real-world performance. Unfortunately, it does take 2 to 3 minutes to produce, and I don't have that much time. So in another terminal, I had already done this, so I can fit it in the evaluation. So as you can see here, it is generating questions, generating 1, 2, 3, 4, 5, 6, 7, 8 questions, and then it is in each question it is answering with the query. And in the end, we get the evaluation report. Total query is 8, average latency, median latency, 95 percentile latency, minimum and maximum latency. So in summary, this is a complete end-to-end RAG service featuring a polite web crawler and advanced retrieval pipeline, robust safety guardrails, and a full evaluation suite. Thank you for your time, and thank you for considering me. My name is Aradhya Verma. I hope to hear from you soon.